Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the concepts of superposition principle for adding functions. As per the problem, use the given graphs for f at x and g at x and superposition principle to graph f at x plus g at x. Write the domain and range of f at x plus g at x. We are given these two graphs. Let's start with part A. In part A, the red line represents the function f at x, the blue line represents function g at x. As per the superposition principle, the sum of two functions can be found by adding the y-coordinates of all points for the two functions at each point along the x-axis. Since we are given the graphs of functions f at x and g at x, we can prepare a table of values to find f at x plus g at x. We can use 5x values from the given graph. Based on the given graph, we can use the x values -2, -1, 0, 1 and 2. At x equals -2, f at x is equal to -1. It's this point here on the graph. G at x is also equal to -1 at x equals -2. Therefore, at -2, f at x plus g at x is equal to -1 plus -1, which is equal to -2. The next x value is -1. At x equals -1, f at x is equal to 0. It's this point, the x-intercept. At x equals -1, g at x is equal to -2. It's this point here. So at x equals -1, f at x plus g at x is equal to 0 plus -2, which is equal to -2. The next x value is 0. At x equals 0, f at x is equal to +1, this point. At x equals 0, g at x is equal to -3, this point on the blue line. So f at x plus g at x is equal to 1 plus -3, which is equal to -2. The next x value is 1. At x equals 1, f at x is equal to 2, this point. At x equals 1, g at x is equal to -4, this point. So at x equals 1, f at x plus g at x is equal to 2 plus -4, which is equal to -2. At x equals 2, f at x is equal to 3, this point on the red line. At x equals 2, g at x is equal to -5, this point on the blue line. So at x equals 2, f at x plus g at x is equal to 3 plus -5, which is equal to -2. So we have found the points that lie on f at x plus g at x using the superposition principle. Now we can use these points to graph f at x plus g at x. For all x values, f at x plus g at x is equal to -2. That means the graph of f at x plus g at x is a straight horizontal line. We can show the horizontal line like this. This line represents the function f at x plus g at x. So we are done with the graph. Now we can write the domain and range of f at x plus g at x. Domain is set of all possible x values for a function. F at x plus g at x represent a horizontal straight line, so there is no restriction on the domain. So the domain should be xer. In the interval notation, we can write the domain as negative infinity to positive infinity. Next, we can write the range. Range is set of all possible y values for a function. F at x plus g at x is a horizontal straight line. That means all points that lie on this line have y value -2. So the range is y equals -2. So we are done with part A. Now we can analyze part B. In part B, function f at x is the red line. Function g at x is made up of two straight lines that meet on the y-axis. Let's start by writing a table of values for f at x and g at x to find the points that lie on f at x plus g at x using superposition principle. Since function g at x is made up of two different straight lines that meet at x equals 0, we can use two x values on the left side of 0 and two x values on the right side of the 0. We can use x values -2, -1, 0, 1 and 2. At x equals -2, f at x is equal to -4, this point on the red line. G at x is equal to 5, this point on the blue line. So at x equals -2, f at x plus g at x is equal to -4 plus 5, which is equal to 1. At x equals -1, f at x is equal to -2, this point on the red line. At x equals -1, g at x is equal to 6, this point on the blue line. So at x equals -1, f at x plus g at x is equal to -2 plus 6, which is equal to 4. At x equals 0, f at x is equal to 0, this point on the red line. At x equals 0, g at x is equal to 7, this point on the blue line. So at x equals 0, f at x plus g at x is equal to 0 plus 7, which is equal to 7. At x equals 1, f at x is equal to 2, this point on the red line. At x equals 1, g at x is equal to 6, this point on the blue line. So at x equals 1, f at x plus g at x is equal to 2 plus 6, which is equal to 8. At x equals 2, f at x is equal to 4, this point on the red line. At x equals 2, g at x is equal to 5, this point on the blue line. So at x equals 2, f at x plus g at x is equal to 4 plus 5, which is equal to 9. Now we can plot these points to get the graph of f at x plus g at x. At x equals -2, f at x plus g at x is equal to 1. So this point here. At x equals -1, f at x plus g at x is equal to 4. At x equals 0, f at x plus g at x is equal to 7. So this point here. at x equals 1, f at x plus g at x is equal to 8. So this point here, at x equals 2, f at x plus g at x is equal to 9. So somewhere here. Now we can join these points. On the right side of the y-axis, the straight line goes like this. On the left side of the y-axis, the points can be joined to form a straight line like this. So this should be the graph of f at x plus g at x. Now we can write the domain and range for f at x plus g at x. Domain refers to all possible x values for a function. The graph of f at x plus g at x is made up of two different straight lines that extend indefinitely on both sides of the x-axis. There is no restriction on the domain, so the domain is just xer. We can write the domain in interval notation as negative infinity to positive infinity. Now we can write the range. Range is all possible y values for a function. As per the graph of f at x plus g at x, the straight lines extend indefinitely along the y-axis in both directions. That means there is no restriction on the range. The range should be yer. In interval notation, we can write the range as negative infinity to positive infinity. We are done with part B. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.